All right, the next problem that I'm going to look at is the one about the tide that fluctuates between 8 meters at low and 20 meters at high tide. You remember we created this equation y equals 6 sine pi over 6x plus 14. You've got all that. Plugging numbers for x, we figured out our maximum and minimum. And now find the equation for the water depth dt in meters as a function of the time, t hours after high tide, which occurred at 3 hours. If I were to graph that equation, which I have highlighted in pink, I would grab my 0 at 14, then 20 at 3, and at 6 we are at 14 again, then at 9 we are at 8, 12, 14 again. This is what it would look like if we graphed the 6 sine pi over 6x plus 14. However, what they're saying, we need to graph it as a function of time, t hours after the high tide, which means that high tide, which happened at 3 o'clock, is our beginning point. What we ultimately are asked to do is to move this to the left by 3 seconds, or 3 hours rather. So I'm going to alter the equation, y equals 6 sine, and it is pi over 6, but now if I need to move my x to the left, I will write x plus 3, and then 3 hours will be our 0 plus 14. So the new equation will be 6 sine pi over 6x, and then pi over 6 times 3 is pi over 2, and then plus 14 as it was. So this right here is our horizontal shift. We're going to move our graph by half pi to the left. The period of the function being 2 pi, half pi is a quarter, which means that our maximum is now going to be over here, then is right here. The minimum is now at 6, and that's our new looking graph. And then at 12, we're back at maximum, 12 hours later. The difference now being that this is 3 a.m. This, in reality, is 6 a.m. And on it goes. When they ask us if high tide is at 3 a.m., when is the first low tide? Well, the first low tide, according to the graph, is at 6, but 6 plus 3 is 9 a.m. And that was the minimum. When we graphed starting at midnight, exactly at 9 a.m., we saw the minimum tide. So the answer is 9 a.m. is our first low tide. What is the height of the water at t equals 11 a.m.? If I look at my old graph, 11 is somewhere right here, a little less than 14. It's hard to tell, so what we can do, we can actually go ahead and plug in our equation, y equals 6 sine. If we're using the new equation, it's pi 6 times 8, because that's 3 plus 8 plus pi over 2 plus 14. If we use an old equation, y equals 6 sine of 11 pi 6 plus 14. And that is because x, they tell us, is 11 a.m. and I'm just straight plugging in 11. I'm going to solve this first because it's easier. If we look at a unit circle, this point right here is 2 pi, also known as 12 pi over 6. And we need 11 pi over 6. Well, 11 pi over 6 is just going to be 30 degrees shy of that. That is 11 pi over 6, which you also can say is like negative pi over 6. And the sine of that angle is negative 1/2. So then if this whole contraption gives us negative half, it's going to be 6 times negative 1/2 plus 14. So 6 times negative 1/2 is negative 3 plus 14 is 11 meters, which, yeah, looks good on the graph. If you were graphing it on a calculator, you could just add x equals 11 for this one, and that would give you an exact point. Or you could add 8 on the new graph, and that would give you somewhere right here, and the height would be exactly the same anyway. To run this down again, we had this original equation, thinking that our time starts at 0, and that's how we graph it. It's the blue graph. But they tell us to figure out a function where time starts counting from 3 a.m., where the high tide is. And for that, we have the red graph and the red equation.